Okay, let's just say there's a car dealership. Now, here's the data for the sales of cars, and here's the data for leases. Now, they've given us the expected value, or the mean, and the standard deviation. Now, remember, we could do that. We could plug that into list 1 and this data into list 2, go to stat, one variable statistics, and don't forget to put that in the frequency list, L1 and L2, and it gives us those values. So let's just say there's two managers. Let's just call them the red manager and the blue manager. So the blue manager is in charge of sales, so he's got a whole bunch of guys out there trying to sell cars. And then the red manager has his team trying to lease cars. Okay, so here's the situation, two managers. Now let's just say that the company has offered these guys incentives. It's a big sales week, right? So they're really going to try to push these cars. So what they're going to do is the blue manager, they're just going to say, okay, you know what? We are going to pay you $20 an hour, but we're also going to give you $75 for every car that you sell, okay, per hour. And then the lease guy, now he's going to get a better rate because they don't lease quite as many cars, and they're going to pay him um, $35 an hour. But what they're going to do is they're going to pay him $40 for every one that he leases. Okay, so there you go. So now the question is, um, which one is better, selling or leasing the cars? Well, let's take a look at what it does to our mean and standard deviation. So for the blue guy, um, he's going to get, so it's the mean is 1.1, and we're going to multiply it by $75, and then we're going to add 20 bucks, okay? And that could be pretty close to what he gets per hour. Okay, so we'll figure that out. And then it would be the same thing for the red guy, right? He's going to get, his expected value is 0.7 times 40, and he gets a flat rate of 35 bucks. Whoops, what just happened? 35. Okay, let me figure that out. So we've got these two situations. Now, just multiply it by the bonus and then add that flat rate, right? And what about the standard deviation? So if you remember, we don't add the constant. That's what that's called. This guy right here. We just do the multiplier for the standard deviation. So let's look at what the standard deviation looks like. Okay, so I didn't do a very good job of labeling this stuff, but here is the new, how much they're going to make per hour, okay? Give or take, plus or minus that amount. That's the standard deviation. Okay, so what if we say, well, they're going to combine their hourly wages, okay, their roommates or whatever. So, um, well, just for argument's sake, we would just add those together. Okay, if we add them up, that would be our new. If we add up, so it's like mu sub x and mu sub y, add them together. Okay, so there's that. But when you add the standard deviations, what you got to do is you have to square them first, add them together, and then take the square root. So let me do that. So maybe we should look at it this way. The owner of the dealership is saying, well, how much am I going to have to pay these two managers? So basically, during the sales week, he's going to have to spend $170 an hour for selling these cars, plus or minus about 75 bucks an hour, give or take. high or low, because it is based on this incentive for the sales. Okay, so there you go. That is like adding or subtracting when you are having two different means together. The big thing is to remember, when you have the standard deviation, square them first, add them together, then take the square root. That's the big deal. Okay, hope that wasn't too confusing, and I think we're done.